Here we have some problems that have to do with circles and equations for circles. And you've probably seen this before. If you've seen an equation that looked like this, x squared plus y squared equals some number, let's say 25, that's a circle. It's a circle with center 0, 0, so there's 0, 0, and a radius of 5. So this over here, that's r squared. So you could write this x squared plus y squared equals r squared. If the center is not at 0, 0, there's another form, the standard form, which looks like this, x minus the x coordinate of the center, so h, we'll call that, squared, plus y minus the y coordinate of the center, squared, equals r squared. So that's standard form, and that's going to come up in these problems. So hk is your center, r is the radius. That's what standard form looks like. So let's say you had a circle whose center was 2, negative 1. We would write that in standard form. We would write x minus 2 squared plus y plus 1, because minus a negative 1 is plus 1, squared, equals, and let's say the radius of this circle was 2, so that would be 4. So that's standard form. But there's another form called the general form, and that's when you multiply these all out. You go ahead and do the squaring, and then you line them up, x squared term, y squared term, x term, y term, the number term, and you set it all equal to 0. If we were to do that with this one, we would get x squared minus 4x plus 4 plus y squared plus 2y plus 1 equals 4. We can combine our like terms here. So we've got a 4 over here and a 4 over here. If I subtract 4 from both sides, those cancel. And now we can kind of just arrange our terms. X squared plus y squared minus 4x plus 2y plus 1 equals 0. So that's this guy, this circle, in the general form. All right, let's look at some problems. This first one says, write the equation in standard form. And remember, that's the one with the h and k standing for the center there. Standard form for the circle with center 2, negative 2, and radius 5 times the square root of 3. Well, let's work on that radius first, because that's what's on the right side of this equation. We're going to square this radius. So 5 squared is 25, and square root of 3 squared is 3. So 3 times 25 is 75. So that's our radius squared. And now we just have to fill in the rest of this formula. We're going to have x minus the x coordinate, so 2 squared, plus y minus the y coordinate of the center, and that's a negative 2, so y minus a negative 2 is plus 2 squared equals 75. And we're done. That's all there is to it. This is that circle in standard form. Let's look at this next one. It says, find the general form of the equation of the circle with center 0, 0, negative 4, and containing the point negative 6, negative 4. So we have a center, but we don't have a radius here. But if we think about this for a minute and maybe do a little plotting, let's see, our center is here at 0, negative 4, and the point negative 6, negative 4 is on this circle. Well, that's a straight line out there, and if that's on the outside of the circle, then that line is a radius. And the distance there is from 0 to negative 6. That's a distance of 6. So our radius equals 6. So we can, I'm going to start by writing this in the standard form, which is x minus 0 squared plus y minus a negative 4, so that's plus 4 squared, equals our radius squared, 36. But we want this in the general form, and that general form, remember, is all multiplied out and put in that order. So our x squared term, x minus 0 is just x, so our x squared term is going to be x squared. Here I'll multiply out the y plus 4 squared. That's going to be y squared plus 8y plus 16 equals 36. Now I'm going to have to subtract 36 from both sides to set this equal to 0 like it is in the general form here. And what I get finally is x squared plus y squared there's no x term, so we'll just go plus 8y minus 20 equals 0. And that is our general form of this circle. All right, let's try one more. And this one is pretty tricky. Requires some geometry knowledge. It says find the equation of the circle with radius 9. Okay, we got our radius. That is tangent to both branches of the graph y equals the absolute value of x. So what is that going to look like? Well, let's just go ahead and graph y equals the absolute value of x. And you should know if you put in 0, you get 0. If you put in 1, you get 1. So on the right here, you get a branch going up like that. It's got a slope of 1. And then on the left, if you put in -1 for x, you get 1 for y. So you've got that sort of mirror image branch going up there. So our circle, if we can visualize this, is just going to be nestled down in there, just barely touching there. We've got our radius. It says a radius of 9. How do we determine the center? Well, one thing we know about tangents to circles is that if you drop a perpendicular, they will connect to the center of the circle. So we can draw those two lines, a perpendicular angle there, so 90-degree angle. And now what you'll notice is that we have a triangle here that has a 90-degree angle, and that should be promising. If we can figure out one of these other angles, I think we will really be in business. And we can, because since this line has a slope of 1, it's got a 45-degree angle right here. So this is actually then a 45, 45, 90 triangle. And we've got these two sides then are the same length. And the radius is 9, so this is 9, this is 9. We want to find the length of this. That will give us the y-coordinate for our center. Well, in a 45, 45, 90 triangle, the sides are in the ratio of 1, 1, square root of 2. So if these sides are 9, this side is going to be 9 times the square root of 2. And from 0 up to here is 9 times the square root of 2. So our coordinates for our center will be 0, comma 9 times the square root of 2. Now we've got a center and we've got a radius. We can go ahead and put this in the standard form. So x minus 0 squared plus y minus 9 times the square root of 2 squared equals 81. And we can just write this as x squared. And we'll leave it in standard form and call that done. So that's a little bit of work with the equations of circles. My name is Larry. I'm a teacher at EdVisions Off Campus. It's an online project-based school in Minnesota. If you're interested, you can check us out on the web at lovethischool.org. Thanks.